Hey everyone, welcome back for a new Zephyr Tech Talk. It's been a while, I think over a month. Summer has been keeping, summer and the new Zephyr release has been keeping people away from, or myself at least, away from YouTube for a little while. We're back. A new Zephyr release is out, and this is basically what we're going to talk about in today's episode. Just a few days ago, end of last week, July the 26th, if you're watching the replay, we have a new Zephyr release that's out. It's actually the new long-term support release of the project. So there's a lot to talk about in terms of new features that landed, and just in general also, I guess it's a good opportunity to discuss about what is a long-term support version in the first place. We have people starting to line up already on YouTube and LinkedIn. So wherever you're joining us from, feel free to do as we often do, which is send a quick comment to say hi and say where you're joining us from. I'm joining from France myself, and we have quite a few guests. It's going to be a record actually today. I think we have about 10 people joining us from all over the Zephyr spectrum. People basically who have been helping make Zephyr 3.7 a reality. Just real quick before I bring everyone on stage. Yeah, Zephyr is out, like I said, and we will discuss with some of the leaders from the community. But our community is actually a lot more than just the people you will be seeing today. There's literally hundreds of people who contributed to this new Zephyr release, over 600. Always nice to see how the community is growing over the years, and people, new contributors keep coming in. So that's pretty cool. Maybe some of you are in the chat. Christopher's from Norway. Wilfried, we know that you're contributing and actually maintaining some of Zephyr, but maybe some of you haven't started contributing to Zephyr just yet. So we can talk about that too. But hello, Gerson as well. Sven, so very Europe focused, it would seem, or today. But yeah, let's bring everyone on the screen. As always, this is going to be I hope, a very interactive session. We want to look back at 3.7, but also hear from you all about some of the things you really enjoyed seeing becoming a reality in 3.7. And we can also talk about the future. All the people I'm bringing on the show today, they have some ideas of topics they want to address, but maybe you too, as viewers and users of Zephyr. So let's bring everyone on stage. Tune. What? We didn't kill StreamYard just yet. Hey, everyone. How's it going?
Good.
All right. Let's do a quick round of intro. I think some of you have been on the show before, 3.7 release party, other tech talks in the past. But let's go in order, I guess. Quick intro from you, Alberto.
Yes, so I'm Alberto Scolar, working for Nordic Semi from Denmark. I have been a maintainer in the project for around 7 years now, and I have had the luck of being one of the two release managers for 3.7 together with Anas.
Nice. Johan?
Yes, hello, I'm Johan Hedberg, working for Silicon Labs in Finland. I've been in the project since the very beginning. I've also been release manager for a couple of releases. 3.5 was the latest one, and also the maintainer for Bluetooth in Zephyr.
Nice. Yeah, go ahead, Chris.
Hi, I'm Chris Freeds with TensTorrent AI. I've been with Zephyr, doing Zephyr stuff for about 4 years, I guess, and manager, maintainer a couple of areas for about 2. POSIX being one of them, and of course, previous LTS release manager with Anas from Canada as well. Sorry.
Nice. Tom?
Yeah, hey. So Tom Burdick here. I work at Intel. I've been at Intel for close to 3 years now, I believe, working on Zephyr. I'm the ITC DMA LLEXT maintainer, and I collaborate a lot on sensors as well. I'm here in Chicago. I've been using Zephyr since just before the 1.14 days. I was an early adopter, I think, on some Nordic hardware. So, yeah.
Nice. And I think I changed the layout, so whoever was ready to introduce themselves next might get confused. Jukka, you go next, if that's okay.
I'm Jukka Rissanen from Nordic Semi, Finland. I have been working with Zephyr since day one, 2015, and I've always been working as a network maintainer, and now together with Robert, I'm maintaining the network stack.
Nice. Ederson?
Hi, I'm Ederson de Souza. Work for Intel, and I've been working with Zephyr for 3 years now, I think. I'm based on Oregon, and I think that for 3.7, I've basically worked on the EDK for LLEXT.
Nice. All right. Oregon it is again. Flavio.
Hey, I'm Flavio Salim. I work for Intel here in US, specifically in Seattle area. I've been contributing to the project for quite a while, and mostly with power management and other areas that I maintain. And I'm the current security architect for the project.
Nice. Yeah, for some reason I thought you were in Portland, but no, that's Seattle, of course. David.
I'm David Brown, Lenaro. They gave us some new graphics. I've been working as it's been a number of years, focused on security mostly. I am a maintainer for the what is that thing called? The JSON support library as well. Also a handful of third-party things that we use, the integration of TFM, the embed TLS, and MCU boot as well.
Nice. And last but not least, Anas.
Yeah, hi everyone. Anas Nashif. I'm based in Montreal, Canada. Been working on Zephyr like a few of the folks here since day one. I'm the TSC chair, and I have, although I was actually on vacation until yesterday, I have been also doing the 3.7 release with Alberto. Yeah. That's it.
Okay. David, you wanted to say where you're from. Go ahead.
Oh, sorry, I just forgot to mention that I'm currently in Denver, Colorado, US.
It's fine. Cool. Interesting that we have lots of people, lots of the panelists are from the US. Lots of the viewing and the watching audience seems to be more Europe-centric, but that's cool. All right, let's see. Bringing back everyone on the screen. Yeah, the way I think we're going to approach the discussion today is, yes, 3.7 was released just a couple of days ago. Some of you might have had a chance to look at some of the highlights, but we're going to walk through them basically again real quick because there's only so much that one can pack into a couple of sentences in the release notes. So and there might be actually more than what's highlighted here than that folks that our presenters we want to cover. But yeah, from networking to Bluetooth to security to LLEXT sensors, there's quite a few things that happen. So yeah, let's try to go in order if people think it's a good idea of some of those high-level highlights. And I'll call on each of you to discuss some more. If you see more that should be covered, we certainly can do that too. And again, to people watching us, and it's more and more of you all lining up, please ask questions. Please comment. There is a comment from Leo from earlier. Send the link to the PR. We cannot promise to review it while we are doing the show, but in fairness, and I think I know I've seen your name recently. In fairness, everyone has been really busy over the past few days and weeks. We've tried and keep and set expectations, especially to new contributors, that their PRs might take slightly more time to get reviewed. So please understand that. But that being said, now we should be pretty much back to normal. So we can have a look. All right, let's see. Yeah, this one is for anyone who want to comment on it, basically. But the new hardware model, there actually was a tech talk about it not so long ago with Carles, I think Anas, you were on, and Torsten as well. I mean, this one, I don't know if anyone wants to comment, but in a nutshell, it's really what it says on the screen. The fact that over the years, the complexity of SoCs and actual boards has increased, has led us to revamp and refactor the way hardware capabilities, or more specifically, like SoCs and boards are being described. Does anyone want to comment more on what this means for folks? And maybe we can maybe sort of jump ahead to the future and forward-looking discussion. Are we done with this change, or do people anticipate more to happen around all things hardware model? Thoughts?
I don't think we are done. We are just getting started. I mean, there is a lot of things that will need to be done as a follow-up that we were not able to do in the last cycle. That would actually would have required a lot of changes that we didn't want to do for last minute for LTS. Many of these things related to testing, to consistency, twister, and to try to harmonize the whole thing. So there will be a lot of work, and obviously, I mean, the feature itself would introduce a lot of possibilities and a lot of new things that can be done and enhanced and improved that we didn't have before, and this will happen in the next release cycle. Yeah, so there is still a lot of work. I mean, the feature itself, as the core of the feature is there, it's complete, I would say. But there is a lot of things that will come after that, and on top of what was already done in 3.7.
Yeah, that makes sense. Yeah, I think let's approach all the other topics maybe in a similar way. We can talk about maybe as we cover what happened in 3.7, we can sort of also discuss what's next, because I think something came in the comments on YouTube recently, like people asking about, like, hey, sensor API, you changed the API, why? And like so maybe bringing more background into why we're doing things, and what's still going to happen in the future might be helpful for folks watching us. Let's see what's next. We have I guess we can cover all things networking, but one, like, I made the same joke sort of in the demo video. It says long awaited here in the text, but I think that's very much true. We finally have an HTTP server library. So Yuka and maybe Chris, you want to talk to what that means and what you anticipate people will be doing maybe with this?
Yeah, it has been kind of cooking for a very long time, and actually Chris started it as a couple of years ago as a Google Summer of Code project, and but then people get kind of prioritized different things, and it was kind of pending for a long time. But fortunately, the beginning of the year, I managed to have some time to kind of finalize things, and also Robert helped, and we have kind of initial version of the HTTP server and a library. There will be new features coming, and APIs will be probably changed a bit. We'll see. And I don't know if Chris wants to chime in here.
Yeah, sure. So as Yuka mentioned, the HTTP server project was initially part of the Google Summer of Code, and the contributor's name was Emna Rekik. So it had a few rough edges when it was first finalized, I guess, as part of the project. Luckily, Yuka had a few spare cycles. I would definitely add more features myself as well. So I think everybody can look forward to some additional features. For example, there's this thing that I kind of probably chose the wrong acronym for called CRIME, which is like compressed resources in memory. And the whole concept there was to be able to grab a static resource without going through the file system. So it should be speedier than going through the file system. And I think being able to take a web root, compress it into a ROM, if you will, and then put that into your flash should be a nice feature at some point. Multiple files all at once, you know.
Nice. One quick question from me. I guess I could look it up, but assuming that I have already like the networking stack set up and like IPv4 or IPv6, whatever, like what's the overhead and what's the footprint of an HTTP server and the HTTP server functionality? I guess, I mean, answer is it depends, but do you have a sense of like, if you're looking at sub-kilobyte, several couple kilobytes?
Well, it's probably more than a couple of kilobytes, and especially if you enable TLS, then it's quite a lot. So it really depends on what you enable and what kind of resources you have.
Okay.
What you want to serve.
An interesting additional fact about it is that it can be done multi-threaded, and you can handle multiple concurrent sessions as well. So it's designed to be to scale down as well as to scale up really well.
Yeah. Okay, cool. That's helpful. Moving on. And again, please, if you're watching us, ask questions. And I think I have a question for everyone watching. Like, what's your favorite feature in Zephyr 3.7? I mean, you might still be discovering some of those if you didn't have a chance to dig into the release notes and you're just tuning into the show. But if you've been paying attention, I'm sure some of you have some thoughts. So please let us know what you were the most excited to see happen. Well, next, I guess we can stay with you, Chris, for a little bit. For the past many years, Zephyr has been sort of building and strengthening its POSIX support. So do you want to talk a bit about what's new, what happened in the latest timeframe, release timeframe?
Sure, yeah. So it's been a bit of a journey. I guess when I took on maintainership a couple of years ago, we had quite a few features. A lot was working. Threads was mostly done at that point still. File system was already basically done. And then I guess as part of the plan for v3 LTS, I just kept adding features incrementally to pad out to what they call the application environment profiles. So that would be PSE 5.1, PSE 5.2, and PSE 5.3, which are respectively the minimum real-time system profile, the real-time controller profile, and the dedicated real-time profile. So at this point now, PSE 5.1 is more or less done. There's a couple of features that we still need to kind of reintegrate. PSE 5.2 is also mostly done, with the exception of some massaging required for the file system. And then PSE 5.3, I think, will be probably the most interesting bit to come in the near future, because mainly this is multi-process at that point. So that's a thing that we've never even touched in Zephyr. So it's quite exciting. And then, of course, talking about future effectively, there's a couple of integration aspects that we would like to fix in the near future. Dependency cycles, unfortunately, like we have a couple in the system. So threading, we've got like C11 threads and C++11 threads. There's a bit of a dependency cycle there. So I'd like to remove POSIX from that equation. And then, of course, the config POSIX net sockets, which is deprecated. So that will see end of life in, I think, 4.1, if I'm not mistaken. And then, of course, I guess at that point, people's imaginations can take them where they will. But I wouldn't say 2025 will be the year of the Zephyr desktop by any means. It'll still mainly be for embedded, so automotive, safety critical. And that's another aspect we'd like to really cover up, is do a real audit of all the safety critical aspects.
Cool. Thanks for the update. Moving on, it's been pretty smooth so far. So this one is going to be, there's so much happening on the Bluetooth and the Bluetooth audio front, then I'm sure we will be spending more than just a couple minutes on this. But yeah, a lot, as always, has happened on the Bluetooth front. So yeah, let's see, maybe, Johan, do we want to kick things off? And then we we dive more into the audio stuff?
Sure. Yeah, so I could mention a couple of things that we got for 3.7. So the UART service, which you, Benjamin, also did a demo of, is something definitely worth noticing, mentioning. And that basically gives you the ability to, over Bluetooth, get access, for example, to the Zephyr console and to the shell, which can be quite nice at times if you don't have, for some reason, the ability to have a physical cable connected to your board. Then we've gotten lots of improvements to the Bluetooth Classic side, the Bluetooth Classic support in Zephyr. It's actually something that's been there since the beginning, but nobody really made any products out of it. And we were almost ready to remove it from the tree because nobody wanted to maintain it until NXP stepped up. And we actually have a proper maintainer now for it. And they've been very active in contributing features and enhancements to that side, especially to the Bluetooth audio-related profiles on the Bluetooth Classic side. We did have a couple of under-the-hood improvements that you don't really see as a API user of Bluetooth for 3.7 that I want to mention. We did some optimizations of the transmission path of data, so we don't have a dedicated TX thread anymore. We're using the system work queue, and we also managed to eliminate some of the data copies when you're transmitting data. So it's you can basically get zero copy down to the driver now, thanks to that. And then another feature which I actually worked on was the redesign of the HI driver API. We've had HI drivers since the very beginning of Zephyr. This was before anything like the current driver and device model existed. And it's kind of been an oddball of a driver API since the beginning. It didn't follow the usual conventions of Zephyr drivers. But now that's been converted to be just like any other peripheral driver API in Zephyr. So it's using device tree and the usual conventions for drivers in Zephyr. Then in the release note, I just noticed we actually got a whole bunch of new HI drivers for the 3.7 release for Ambic, for NXP, for Infineon, for Renesas, and so on. So there's clearly lots of activity on the Bluetooth front in Zephyr for adding new platforms.
Nice. Do we have, yeah, we have Emil backstage. Let me just bring him in. Emil, did you want to add some more color to the stuff that happened on the audio front?
Sure, I can say a few words about LE audio. I'm not involved with the classic audio that we have also.
And
had
hi,
some
by the way, because I
improvement.
realized that we didn't. You were not part of the initial round of intros. Hi.
Hi. Yeah, I can do a quick introduction myself. I'm Emil. I'm also working for Nordic Semiconductors, also in Denmark. And I've been a maintainer for the LE audio subsystem for 5 years now.
Nice.
And yeah. So for the 3.7 release, there hasn't been any significant new features for LE audio. It's actually been nearly feature complete for a few releases now. So right now we are focusing on improving documentation, stability, optimizations, and basically working towards making it more ready for a real life product. But still a way to go now, but we are slowly getting there.
Nice, cool. Thanks for the update. And people are pretty quiet in the comments, so I hope to see more engagement from everyone. But let's see, moving on. I think next is on the topic of sensors. Of course, over the years, I mean, I stopped keeping track, but there's literally hundreds of sensor driver implementations in the Zephyr tree. But a lot of work went into improving, revamping the sensor abstraction model, sensor API. In 3.7, we have Tom as a maintainer from the sensor subsystem. Do you want to tell a bit about what that means? And I guess for this one, it's also one of those areas where you may want to talk about what's next, because it's probably still a work in progress in many ways.
Yeah, absolutely. So sensing the sensor API is sort of it's been a long-lived API in Zephyr, and as I mentioned, I first tried using Zephyr back in the 1.x days with that sensor API. I've had it in my mind since then that there were a bunch of things that I really wanted to try to work on and fix and improve. So in in the latest LTS release now we have a new API for reading and then decoding, and this is quite different than the existing fetch and channel get API. So the current the previous API would let you ask this tell the sensor driver, hey, go fetch data, maybe one channel or a set of channels, and then you could obtain that channel data that would be converted into like a struct sensor value with a whole number and a fractional number part as part of the struct. Individual channels you go fetch, right, or get from the sensor driver. Well, the sensor driver was holding on to the raw data. It was doing the conversions for you. That's not necessarily what many people want. Many people wanted to simply read the data off the device and ship it off to a phone or a computer, right, and then do the work there. Sometimes you may just wish to use the raw data to actually do digital signal processing on, since it's typically a compact, sort of fixed point format in itself from the device, which is convenient for doing, some integer signal processing on. So read and decode allows you to do that. Read will read the raw sensor data, ideally into a buffer that you give the sensor device driver now. We're still going to work on improving how that's done. But then as a secondary step, you can optionally take that buffer of data from the device sensor and decode that. And you can decode it into arrays of like channel data. So if you have temperature data, humidity data, and pressure data, and maybe there's the readings, there may be more than one reading. Let's say the device had a FIFO. You can now read all the temperature data into an array, all the humidity array data into an array, and so on, and then process that as you normally might. So there's some large changes there. We no longer use struct sensor value. We now use a 32-bit fixed point value with provided shift. So the shift decides where the decimal goes, basically. What else can I say about this? I think maybe the more exciting part about all this is where it's going and what we're looking at adding. So the next steps are kind of working towards improving integration with the sensor subsystem that another group at Intel has contributed to Zephyr. And perhaps providing some tools around that for debugging and visualization. I would love to work towards that. There's also, sort of this need to deal with dealing with various triggers. We have that now at 3.7, but it's not. There's basically one sensor driver that uses this. So it'd be really great, following 3.7 to sort of improve driver support for this API. And the underlying needs of this API. Yeah, so.
Nice, cool. We have a question from the audience. Chris is asking, does the new sensor API support time spreading, i.e. Attaching timestamps, basically, that may be used later on for things like sensor fusion and the like?
Yes. Yeah, so that is another key aspect of this new API, is that it intentionally does add timestamps. So each sample or set of samples, if you're dealing with like a FIFO from the device, gets a timestamp, and you can infer timestamps for each sample in the array. The way it also generally tries to improve like how accurate that timestamp is. So the older sensor API, the timestamp may actually be quite a bit different than when the sample occurred, which is terrible for sensor fusion, as I'm sure many of you are aware. Time is a huge part of it. You need to know when the sample happened in order to do inference and sensor fusion. So being able to basically capture, ideally, the exact moment that you get like a GPIO interrupt that says, "Hey, the data's ready," or the FIFO watermark has been hit, or some other event has happened, is really crucial to capturing that timestamp accurately. The older API would basically punt off when you would get a callback to a thread. So the GPIO interrupt might happen really quickly, and then it would enqueue like a K-work task, or give a semaphore to a thread to then go do the work. At that point, you could capture a timestamp if you wanted to, but it would almost certainly be wrong. Especially if you're using Bluetooth. Bluetooth loves to just sort of hog things up, particularly with K-work involved. So you could be delayed quite a lot from when you would actually capture that timestamp. So today, the way this works now is that we actually take the GPIO interrupts, and you don't get a chance to actually directly inject a callback. You just basically say, from the driver API, I want to capture these events, and I want to optionally read data when these events occur, and the timestamp is collected for you on your behalf, and as accurate as a manner as possible. So some benefits there.
Cool. That's nice. Thanks for the update. Thanks for the question, Chris. We have a question that from Thiago around the HTTP server. We will keep it for later, but just a heads up, Thiago, that we did get your question. And people commenting on the fact that they really appreciate how many drivers are basically available, readily available in Zephyr, as opposed to other frameworks or RTOSs where it's more bare bones. So yeah, I couldn't agree more. And moving on to LLEXT. So reasonably new feature from Zephyr 3.6, the ability to dynamically load modules in a running Zephyr environment. And in the 3.7 timeframe, there's at least one thing that got added to LLEXT, which is the new extension. It says developer kit, it should say development kit. Actually, that's a typo, I guess, not that people would mind. But Ederson, do you want to talk to what that means and how you anticipate people will be using this feature?
Yeah, sure. Now that you are able to load extensions into Zephyr, you can load these modules that you can run code. One thing that you may think is like, I don't want to be building all the extensions. Maybe you want to create like an ecosystem, and you want like a third party to be able to create some new feature for your device, and then you want them to be able to build an extension. But at the same time, you don't want them to like have your code and send you your code, and then you have to build, and then it kind of becomes a mess, right? So with the extension development kit, it's basically we export all the headers and the flags that were used to build the Zephyr application into a tarball that you can send to your third-party developer. And the third-party developer will basically include that in their build system, so they will be able to build the extension without having access to the code. Then they can send you the code, the build extension. How you'll be doing that kind of depends on your ecosystem. But the idea that now you are able to build an extension for a given Zephyr application without needing like the source code. So you just need this set of APIs. So it's basically a set of headers. So you now can have a new target on your on Zephyr, and you west build -t LLEXT CDK, and you have like the starball that you can then distribute, and people will be able to develop extensions for your application. So that's basically the idea, and I think that the sky is limited here, because like if you are able to create some of this ecosystem, then I think that your application they have some new features that you were not even expecting. And of course, you can create your application. These APIs, the APIs are exposed are not only Zephyrs, but your own application. So if you have like a special API that you want people to be using, that will be also available to them, and it's really nice. One thing to note is like this is only about the APIs, the headers, the tool chain. You still need to send to your third-party developers in some out of band way if you're using some special tool chain. But yeah, that's really cool.
Yeah, or they could use the tool chains that Zephyr provides. And I actually did the demo of the new EDK as part of the demo video we put together for the release. It was really nice to be able to just bootstrap a complete environment in literally minutes, because you really, it's really just a bunch of headers like you described. So that's pretty nice. Quick question, maybe to you and maybe Tom has thoughts as well. Like anything we can expect to see for 4.x, for LXT in general. Any ongoing work that you know already about?
Yeah, I mean, I think Ederson, I don't know if you want to take it, but okay.
I think you're more aware of the next things. I mean, for the EDK, it's probably maybe thinking of a way of supporting the new how is it called, the lead linking. That's a really nice addition that like allows a smaller binary size, because instead of having like the name of the symbols on the application, you will use it an ID basically. But that's not compatible with the EDK right now. There would be more things to be added to support that. But on the LLEXT side, I think that you can say add more things, Tom.
Yeah, so I mean that was a great. Thank you for bringing up the SLID linking. So that was a great feature contributed by, I think it was I'm gonna butcher the name. It's Matthew, I think, from ST contributed that fantastic feature. Basically removes, as Ederson said, removes all the textual symbolic names that you'd normally have to go match up, and replaces them with a hashed ID. Again, making the ELF smaller and linking faster. I think broadly, LXT will, in the 4.x timeframe, I would expect us to see, wider architecture support. So right now that we support ARM, Cortex-M, Cortex-R to some degree, and Extensa. I would expect to start seeing, perhaps x86, ARC, maybe RISC-V support being added for LXT in the 4.x timeframe. There's also some potential to support other or more varied linking of ELFs. So right now the Extensa linking that we support, the linkage that we support for Extensa is slightly different than the linkage that we support for Cortex-M. Ideally, the optimal linkage that we can support is static linking. So we kind of do the last step that a linker would do as we're loading an ELF. But there's some downsides to that. One is, that we can't do execute in place necessarily as easily as we could if we were doing FPIC or right, position independent code with dynamic linking with like a lookup table. So yeah, there's a lot. I think there's a lot of work that's going to happen there to improve ease of use, size of these ELFs, and yeah, I think it's there's a lot of great work going on from Intel and the rest of the community, ST, Arduino, lots of great work. So
yeah, it's been pretty awesome to see how it went from like almost, I mean, I wouldn't say a one-man show, but just a couple of people working on it to literally like several huge organizations embracing it in just a matter of months. So yeah, that's cool. And I think who was that in the chat? Yeah, Victor would agree. Victor said that it's top among the latest additions to Zephyr. Really cool. Moving on, another highlight from the release is around, and I'm sure there's more that happened, and we will ask Alberto what went into native simulator over the past few months. But one thing that I found was quite interesting is the ability to basically, when you're running Zephyr on your host development environment, just completely rely on the host networking stack, whereas in the past it would have been slightly more complicated. So, Alberto, do you want to talk to that and maybe other things that went into native simulator recently?
Well, actually, maybe Yuka is best to comment, given that this is very networking related. Yuka, do you want to comment a little bit about this offload the sockets?
Yeah, well, it's so there's a new network driver for native SIM that allows network connections without any root access in the host side. So there's no TUN device connected to this, and yeah, it's not for everyone, but for simple cases, it's quite convenient to use.
Yuka, is that entirely in user space then?
Yeah.
Oh, wow. Very cool. Yeah. Because that would work as well as like a Docker environment, I suppose. Then.
Yes, yes.
Excellent. Thank you.
Great. And Alberto, was there anything else you think would be worth mentioning on native simulator front?
Well, it has mostly just reached the level of maturity where in the next release we will actually be deprecating native POSIX. So I don't know if that is, much of, I mean, it's not, it's just a qualitative change, not a quantitative one. So the idea is that in 4.0, probably next week, I will be, deprecating native POSIX, and in 2 releases we will be removing it. Now native SIM should support everything that native POSIX supported. So I hope that people will be happy with this change.
Nice, cool. Thanks for the update. Okay, and to everyone who's been commenting or asking questions in mostly on YouTube, it would seem today, we do have your questions, and we will be taking them towards the end, which we are getting close. This one, I'm really excited to hear what Flavio, David, and maybe others have to say, because half of those acronyms, I have to admit that I myself don't necessarily really grasp all what's behind them, whether it's an ARM-only thing or whether it's applicable to really all platforms. But just some of the updates that went into 3.7 were basically along the lines of making sure that some of the security frameworks and libraries that we use for this new LTS release were effectively upstream LTS releases from the respective upstream projects. But yeah, the whole PSA crypto stuff, please tell us more, guys.
Yeah,
give it a try.
Yeah, sure. So I can start. So for this release, we have engaged with the TFM folks and worked to align our release with TFM and Embed TLS. Both projects have done, LTS releases around the same time as ours. So this is good because using these LTS versions, we ensure that we can receive security fixes throughout the entire support period for 3.7. So as you mentioned, from my perspective, the biggest highlight is the adoption of the PSA crypto as the full cryptography API. Just to contextualize why I think this is important. Until now, cryptography on Zephyr was provided by TinyCrypt and Embed TLS. And one problem that we had is that part of Zephyr was using TinyCrypt, other part was using Embed TLS, and depending on your application configuration, we could end up with both libraries for providing the same cryptography primitives. On top of that, we have crypto drivers that it's a way to enable hardware accelerators, but it's not fit super well in the whole crypto context for Zephyr. So, and obviously, last but not least, TinyCrypt is no longer maintained, and so we can't rely on this project to support cryptography on Zephyr. PSA crypto, it's a new implementation. Let's say it's a new the interface for crypto, and address all these problems that I mentioned and provide additional features. And I'm very excited to have these. Just to clarify, PSA crypto, it's not platform specific, so covers all the architectures and everything that is supported by Zephyr.
Do you want me to give a little brief description of what all the acronyms mean? That might be
yes, please.
Yeah,
yes.
that's good.
I assume that people don't necessarily know what those acronyms are, and also what I would love to get like your quick explanation on is, I mean, my understanding of TFM is that the M is for Cortex-M. So is TFM relevant for people who don't care about Cortex-M and run on other architectures? And similarly, is PSA something that's ARM only or more? Yeah.
Okay, so you're right. The TFM is the Trusted Firmware M. It's part of the trustedfirmware.org. It is a trustedfirmware.org project to provide an implementation of basically the PSA architecture for the Cortex-M processors. So the PSA itself is a spec of security requirements, standards, certification. There's a lot of stuff that's covered in it. It's platform security architecture is what it means. There's nothing inherent about it that is ARM specific. It's just ARM created it, and they have this as kind of the first implementation of it. Part of that spec is for cryptographic primitives. So the spec is broad. It covers the entirety of the system. Specifically, TFM is a secure enclave. So it works on these processors which support a separation between a secure and a non-secure. And TFM is the implementation that runs on that secure side of services, secure storage. There's different kinds of services available there. So the embed TLS library is also now part of this trusted firmware. It is a cryptographic library. It provides TLS support, which is part of the kind of the big part of the name, but there's also an underlying cryptographic primitive library. And it's been under a process of transitioning from its own ad hoc API to the cryptographic API specified by this PSA standard, the PSA cryptographic API. So now that that's available, as Flavio mentioned, we're using that API as kind of the official-ish API to do cryptographic operations within Zephyr. And that library is completely platform agnostic. There's ongoing work to improve support for hardware acceleration and that kind of thing. So the idea is that code should be able to just use these primitives, and then someone can provide their own cryptographic operation in the framework provided by Embed TLS to get support for their hardware. And that, as we mentioned, is ongoing. Yeah, so those are the two main pieces I think that were mentioned in there. And the big thing to reemphasize is we got everybody to agree on what LTS means and when that happens. There's still some issues about how long the L is for long-term support and trying to get when these overlapping intervals. But the goal is to get it to where the components, especially significant security components that go into an LTS release of Zephyr, will also have the same level of support as the Zephyr code itself. So,
right.
Yeah, so we can add, that this always started because in the previous LTS release we had a problem where the TFM that we are using was not a LTS release, and we stopped getting security fixes, and at some point we had to deprecate it because we couldn't move to a newer version because of API compatibility. And also, the backporting, the issues for the fixes for the version that we are using were not doable. So we start this conversation with this other project, trying to align our LTS with their LTS. So,
Right. Okay, cool. So yeah, based on this sort of acronym soup, which, by the way, David, you did a great job at sort of walking us through. Based on Victor's comment as well, I would love to have a tech talk on all things crypto and security in the near future, walking people through some of the use cases, etc. So hint, hint. But yeah, no, thanks for the update. All right, I think we're doing pretty good timing-wise. Quickly going back to the release notes. A few more things. I guess this one will be an excuse maybe to go to give the mic back to Yuka to see whether beyond the HTTP server there were other interesting and noteworthy things happening on the networking front. I think there were some performance work and performance improvement also happening. The precision time protocol is one too. So yeah, Yuka, was there someone else worth adding or mentioning?
Yeah, well, we have improved the TCP performance, but that will come in 3.7.1. And as you mentioned, BTP is there, and we have had already the GPTP support for many years, but this BTP is like a sibling for that protocol.
Yeah.
And then some minor comments. We have a DHCP vendor-specific options supported now. We can support MDNS responder and resolver at the same time. We have IPv4 address conflict detection support. We have IPv6 privacy extension support. We have structured locking for using TCP for syslog. Yeah, perhaps those are kind of a short, quick mention about new features.
Great, cool. Thanks. So yeah, with that, I think we're mostly through what was highlighted in the release notes. I should put the link maybe again if people want to learn more, want to read more about what happened in the release. This is the blog post that went out on last Friday. There's also tons of demos being featured in there. And with that, yeah, let's see some of the questions that we haven't addressed just yet, and then we can finish maybe by a quick roundtable of what people have on their minds for 4.x, in case we haven't covered it already. So let's see. I'm going to try and go back in time. Thiago, I think I promised we would be coming back to you. You were one of the first questions on the topic of HTTP server. Could we expect that the compressed resources emulate a file system that we could generate in a C file, a la Qt's QRC, whatever that is? Chris, yeah, that's. I think that's kind of related to what you were mentioning, right?
Yeah, I think that's a great question, actually. So one of the things that we want to achieve with the compressed resources in ROM is essentially to minimize the overhead with all of the kind of file lookup and stuff like that. So yes, we could definitely generate a C file. Whether or not that's what one would necessarily anticipate when looking at a C source code file is another thing. So effectively today we do we include a pre-processed binary as a header file. There are actually CMake extensions in Zephyr for doing just that. And I should note that actually, I think it's ISO C23 has a embed functionality, much like include. So you can actually just embed a file right in your source code. But on that topic, I think one thing that we might want to take advantage of for this sort of thing is gperf, I believe it's called, which is used for perfect hash table generation. So that would mean we'd get a perfect hash function matched specifically to all the compressed resources. And then you would just get instantaneous lookups. And yeah, you would have that in a C file effectively.
Great, thanks. Thanks for the answer. Another question was from Ben on the topic of crypto. Thank you for the details. And is there any timeline for supporting hardware acceleration for e.g. TLS?
Yeah, that is on plan. So let me put this way. This is being still defined in the TLS. So they are still working this driver interface. there is a still discussion where these drivers will live. We've been discussing this on Zephyr, if it would be the one that will be hosting these crypto drivers, or if they will live, in an external repository that would be shared across, other projects using PSA. A specific date, I'm not aware yet, but that is something that is happening right now in this discussion, in the work on this.
Okay. And did I mention we should be doing a tech talk on all things security? There's tons of questions. One more from Vishal. Can PSA extension be used for Cortex-A, or is it Cortex-M only?
Well, if he's if he's asking about PSA crypto, that it's platform agnostic. It works not only for ARM but also other architectures, and obviously Cortex-A and M.
Okay, but would people get more security or more performance on if they target ARM architectures, or better integration, or not necessarily?
For the crypto, no, there is nothing really tied to the
just
platform.
APIs, basically.
It's just APIs and the definitions.
Right.
Obviously, if you are using TFM, you can have the API provided by TFM, so you can put this in isolated context and basically use TFM for that. But what we are talking here is at the API level.
Okay, cool. So we have a few minutes left. I mean, we can always go over time. At least I can. Yeah. So, question to everyone, to all our panelists: is there anything we forgot to mention from 3.7? I guess we didn't spend so much time talking about the fact that it was in the LTS. So maybe we want to talk about that, or I promised that too. Looking forward to 4.x and what's in the roadmap now that the merge window has opened, and now that people are back to implementing new features for the next release. Are any of you already thinking about something big that you want to tackle in the 4.x timeframe? David, I know for a fact that you are. I don't know if you want to briefly mention what you've been working on. It's been getting some community attraction. I'm not asking you to do a tech talk just yet on this one.
Okay,
but,
that's good. Let's get at least one PR merged before we do the tech talk.
That's true.
So I've been working on actually supporting Rust kind of first class as a thing in Zephyr. I've got one PR sitting there ready to kind of start massaging now that the merge window's open back up, and the rest of it is I mean, I have a lot more stuff coming, including pretty native integration with device tree in Rust code that you actually just specify. I mean, I could actually just say Zephyr : device tree : chose aliases : LED 0 : get instance, and I have a thing right there that's my LED, and I can use it, and hopefully a lot more coming from that. So it's it's right at the beginning stages. We have a channel on Discord. It's probably a good place to poke at it, or search for Rust. There's an area for it for PRs if you want to look at them, give feedback, that kind of thing.
Great, thanks for the quick update. Anything else people have on their minds?
I could add something if no one else has anything else. Yeah, so I think it's been publicly announced already by my senior people at TensorFlow, but we're actually pretty committed to open source everything. So that includes Linux all the way down to the firmware running Zephyr. And so actually have one of our cards, but pretty soon you should expect to see open source firmware running Zephyr for our cards. And we also license our IP too. So that should trickle down to whoever in the community wants to license the IP to put in their own chips or whatever. So.
Cool. Anything else from folks?
I could mention.
Yeah.
We have the native Wi-Fi coming in for 0. So there has been a Wi-Fi support for quite a long time now, but it has always required that the stack is offloaded to coprocessor. But we have the native Wi-Fi coming, so there will be WAS applicant, and both Nordic and NXP are providing driver for this. So that's nice.
Cool. Quickly on the topic of interesting languages, any Zig support on the horizon? Any of you guys looking at Zig, interested in Zig?
I played with it a little bit.
Or I guess another way to look at it would be, would any of the work that you're looking at, David, would enable more easily integration of languages? Like Lua comes to mind too, but would in your opinion, would that make it easier to integrate?
Zig more than Lua, but not really. I mean, there's not a lot of overlap.
I was thinking more like build infrastructure-wise and things like that, but okay.
The improvements that make it easier to deal with another language will definitely help with other languages.
We should have a LLEXT being able to load like a Zig or Rust or things. It would be nice.
Not necessarily like a firmware language, but I think it would be really great to include some integration for hardware software co-design. So introducing some support for RTL like Verilog or VHDL, or even newer languages like Chisel or whatnot. That'd be a really interesting thing to see from the IP bring up perspective.
Yep. All right, and with that, I know that some of you guys have to run. I think that's a wrap. We will be back next week. I should have prepared the trailer and the promotion for next week's Tech Talk, but we will be back next Wednesday, same time, but next Wednesday for a Tech Talk on all things observability and extracting data insights from running IoT devices, and after that, next speaker could be you watching us. Like if you want to present something you've been working on in the context of Zephyr or just embedded in general, feel free to ping me, and maybe we can have you on the show. Thanks everyone watching us, and thanks to all of our panelists today. I think this was pretty cool, and we should do it again for 4.0, right? Thanks. Bye.
Bye.
Thank you. Bye.
Bye.